Hi and welcome to this ADF Academy video presented by Comsys. My name is Christian and today I'm going to show you how to do a commissioning in sensorless control. The Comsys active filters are the only active filter in the world that can run sensorless control, and sensorless control means we're running without the use of current sensor. If we open the web interface and look in the setup window, we have here the CT connection. We can have closed loop, open loop or no CTs. You can still connect it CTs and run it in closed loop, still operate the active filter in sensorless. What you need for sensorless is one of the license keys. So just make sure you get a license key from Comsys and then you'll find to run it sensorless. We're going to keep right now the CTs on here. There are some CTs connected, so we will also see a little bit current running here. To do the sensorless control, we want to open a few windows. An important window always to have open is the measurement window, and then having a waveform open is quite nice. Here we see right now the current distortion. Here we have now the voltage distortion, where we can see there's quite some distorted voltage here. And the spectrum as well, we can have it as voltage distortion. Right now you can't see very much, it's very tiny down here, so we do a scaling to just see the harmonics, and now we can see that we have a large amount, 5th, 7th, and then 11th and 13th harmonic. The last window that we need is the compensation window. Here in the compensation window, as standard, everything is deactivated. So first we have to activate the harmonics compensation. We can do that now in CT control or sensorless control. If this one is grayed out, you still need a license key. Make sure you send in the about window the SSC2 identifier to Comsys, and with this identifier we can give you the license key. Now we have the possibility here to activate the sensorless control. There's a small difference in how the active filters are configured. In current control and CT control, the settings that we write here is the degree of compensation. In sensorless control, it is actually the percentage of capacity. The degree of compensation can't be used for sensorless control, because we would always need to know what is 100%. In sensorless control we miss this information. The information what is 100% of the voltage distortion gets lost in the process of compensating. Current control we always have that information available. So that means in sensorless control our target level is always 0% distortion on a single harmonic. The question is just how much harmonic current are you giving the system to operate here. This is now a 120 amp system, so if I would add 10% on the 5th harmonic, that means I'm able to give out 12 amps to compensate the 5th harmonic over here. So we're gonna just start the filter quickly, then we're ready to operate. And with the filter started now, we can start to add some values to the compensation, and we can see how the filter reacts. Right now we have on the 5th harmonic 8 volt. We typically start with a relatively small value on the sensorless control compensation. So we start with 20% on the 5th harmonic. 20% now means 24 amps that we can give out to reduce the voltage distortion on the 5th harmonic. If we apply the setting now, we see the 5th harmonic is dropping down. When we see that's dropping down, then we're fine to increase the value a little bit further. Let's go to 60%, and with 60% we are pretty far down already. We have already an output current of 56 amps. So it's actually not using the full 60% that we're allowing the filter here, but this is all the filter can do at the moment. Now we can add a little bit to the 7th harmonic, 30%. and that one is kicked down as well. We're now already at 2.3% on the voltage distortion. There's still a little bit on the 11th and 13th. We can just put a little bit percentage to compensate on the 11th harmonic as well. We drop the 11th harmonic a little bit down, and also the total voltage distortion drops a little bit. This is already enough in this particular case to run the active filter. We don't need much more than that to compensate. So you see in sensorless control, typically the values that you add in the settings here are much smaller than the settings that you would add in current control. And typically also it's not that many harmonics that you activate. You see now the waveform is a very nice sine wave. If we deactivate that again, we're coming back to the distorted sine wave. So there's a very clear difference that we can see with active filter running and active filter not running. That is all for today. Thank you for watching and see you soon.